Okay, hi there, gang. Here we are going to try to solve this triangle. We want to find the angle theta, the distance d for the following right triangle. So we want to find this angle, theta. We also want to find this side, x, as well. I meant to write that in this question. Um, so I would like for you all, please, to pause the video and try to solve this triangle using trigonometry, and see if you can do it to find the angle theta and the side x, as well as the distance d. Go ahead, pause the video, and see if you can do it. Okay, let's go ahead and solve this. The first part, and you can do this in a number of different ways. You have options here. The first way I'm going to solve this is to find theta. And the way we can find theta is very easy. We know that the sum of all angles in a right triangle must equal 180 degrees. So this angle is a 90-degree angle. That angle is 121 degrees. So we could say that 180 degrees minus 21 degrees minus 90 degrees equals theta. And doing this, we can find out that theta is equal to 111, which is going to be 69 degrees. 59 degrees. Yeah, sorry, 59 degrees, excuse me. Cool. So there's our theta. That's the easiest part. There are other ways you can find this angle theta, but that way we'll do for the first part. Okay, so now let's go ahead and find the side. Let's go ahead and find the side x here. And you could do this in either order. If you want, you can find d here, but we're going to use SOHCAHTOA to find x. SOHCAHTOA is a set of trig identities, which is that sine of some angle equals the opposite side over the hypotenuse, cosine of some angle theta equals the adjacent side over the hypotenuse, and tangent of some angle theta equals opposite over adjacent side. Opposite and adjacent have to do with the angle you're looking at. The opposite one is the one that's across from it. They're not touching. The adjacent side is the one that is touching. So for instance, 21 here is touching this line. It is not touching this line. So I would call this side for my 21 the adjacent side. I would call this side the opposite side. And then the diagonal line, the long one of your triangle, I would call the hypotenuse. If we're looking at this theta over here, then I would call this the opposite side and this the adjacent side. And all these functions will give you the same value for any of these. Okay, so just so you know, I'm going to go ahead and do this looking at the 21-degree angle in the bottom part of this. So I know the length of the opposite side. I don't know the length of the adjacent side. I do know the magnitude of the angle. So because I want the adjacent and I know the angle and the opposite side, I'm going to use tangent for this. So I'm going to say that the tangent of 21 degrees equals opposite, which is 9 over adjacent, a. Solving this for a using algebra, I can multiply both sides of this by a, and I can say that a equals tangent of 21 degrees divided by 9. Now, you can and probably should just use a calculator to evaluate your trig functions. The thing that's really important, you can't do a trig function with a bare angle. You're only ever going to do trig functions uh, of measured angles. So basically, I will never multiply a 21 by anything if it's an angle. I'm always going to put it into a trig function first. So tangent and sine and cosine make those measurements into numbers out of a function. So tangent of 21, according to my calculator, is 38.3. Divide that by 9. I'm sorry, that's so silly of me. I can't believe I made that mistake. Sorry. A is not tangent 21 over 9. It's 9 over tangent of 21 degrees. Pardon me, sorry. Still a mistake to make, but yeah, if we're dividing, we're going to get the a by itself. We're going to put the tan 21 at the bottom. Okay, so it's 9 divided by tangent 21, which is in fact 0.3 something, and we end up getting a equals 23.445. So we end up getting that for our angle A. Now, the last thing we want to do is we want to find the hypotenuse of this triangle. We could do this using the Pythagorean theorem. The Pythagorean theorem is your two sides squared. We call them A and B. Which one you call which doesn't matter. And we call that one C. The Pythagorean theorem says A squared plus B squared equals C squared. So we can say A is 23.445. I'm going to round that to 23.4 squared plus B squared is 9 squared equals C squared. Now all we have to do is solve that for C using algebra. So a squared, put that into my calculator here, is going to be 549.7. I'm running out of space, I apologize. Plus 81 equals C squared. So add 81 to that. I end up getting 630.7 equals C squared. Take the square root of both sides, put that into my calculator, and we will see what we get. 25.11. Oopsie. So using these methods, we found C, we found A, and we found theta. So again, this is probably review for most of you guys. The main things that I would look out for here are, like I said earlier, all your angles in a right triangle have to add to 180. Your two regular sides squared will give you your hypotenuse squared. Remember your trig identities, and remember never, ever, ever use a bare angle in math. You will always convert it from a function into a number by using sine, cosine, or tangent. Okay, cool. Let's look at the next example. Here are 3 algebra questions that we're going to try to solve. So once again, please pause the video and try to solve these 3 algebra questions. Okay, so let's try to rearrange all of these expressions for their given variables, starting with the first. So all of these, by the way, are equations that you will end up seeing in physics. The bottom one is more of a specific edge case, but in all these cases, these are functions that you should be able to evaluate. So we want to get VS up to the top and solve VS so that it's by itself. Sorry, I'm trying to mess with my scaling. I want to make sure I'm able to see this, but not be cramped. Okay, so I get F naught equals 343 minus V naught over 343 plus Vs. All of this is multiplied by Fs. Okay, so I'm going to go ahead and get rid of this Fs first. Do that by dividing both sides of the equation by Fs. I will then have F naught over Fs equals 343 minus V naught over 343 plus Vs. All right. Now, I want this Vs on the top, so I'm going to multiply both sides of the equation by this bottom quantity, 343 plus Vs. So multiply by 343 plus Vs, which will cancel here, and then multiply this by 343 plus, oh geez, 3, 4 plus Vs, boop, boop, and it's multiplied here. All right, so we end up getting F naught times 343 plus Vs over Fs equals 343 minus V naught. Okay, so now I want the Vs by itself again. We're going to get rid of this Fs on the bottom. So I'm going to multiply both sides by Fs. Over here, I will multiply by Fs. That should be in parentheses probably. I end up getting F naught. That cancels here. F naught times 343 plus Vs equals Fs 343 minus V naught, like this. Okay, I can divide this by F naught to get rid of the outside part. That cancels here. And then the last thing I can do, I get 343 plus Vs equals Fs over F naught times 343 minus V naught. Subtract 343 from both sides. And I'm getting Vs equals Fs over F naught, or F0, times negative V naught. And there we go. So that's the first part of algebra. Now let's solve this next expression. Fg equals gm1m2 over r squared for g. This is the equation for force of gravity. I meant to mention earlier, this top one is for the Doppler effect. So changing in frequency of sound based on the relative velocity of the source of sound and observer, that is the Doppler effect. That's the top equation. This bottom one is for gravity. This bottom one, very bottom one, is for trig. Okay, so we get Fg, oopsie, equals gm1m2 over r squared. So I want to get this g by itself. We're going to multiply both sides of this by r squared. That kills over here. We get an r squared up top over here. Then I have r squared FG equals G M1 M2. Divide both sides of this by M1 and M2. And we end up getting FG equals, excuse me, I should write this differently. We get R squared FG over M1 M2 equals capital G. And there we go. Okay, last part. This one's a little bit tricky. We have a squared plus b squared minus 2 cosine theta equals c squared. So let's try this last one. We have a squared plus b squared minus twice the cosine of theta equals c squared. Okay, let's get this theta term by itself. We want to solve this for theta in this case. Solving for the angle in a trig expression can be a little bit tricky, but let's see if we can try it out. So first things first, we want to get this cosine theta term by itself. We're going to subtract a squared and b squared first to that extent. So we get c squared negative 2 cosine theta equals c squared minus a squared minus b squared. Divide this. I want to get the cosine theta by itself. Minus 2, divide this by minus 2. So I can write cosine of theta equals negative c squared plus a squared plus b squared over 2. I use this minus to get rid of the minus up top. So to solve for theta, we got to solve for the cosine first. Then once you've got it in this format, you have to use the inverse version of that trig function. So we're going to do arc cosine, which is the same as saying cosine, oh geez, to the negative first power. You also heard this called inverse cosine probably. Your calculator will usually have it be another function of cosine. It's second then cosine. So like the alternate mode for a button and then the cosine button again will give you this usually. So then we're going to take the arc cosine of whatever this function is. Negative c squared plus a squared plus b squared halves. And sorry, it's the function arc cosine times this. That gives us our theta. So basically, the arc cosine undoes the cosine part and gets theta by itself. So you take the arc cosine of this function, you could do that if there were numbers for this, and then what your calculator gives you back will be a angle. All right, everybody, we got one last question for the math review. We're going to take a look at graphs. So here's a graph of an object's velocity versus time. You'll be seeing a lot of these later on down the road. They're very, very useful for the beginning parts of our physics course. But for now, I just want to make sure that we're comfortable reading graphs and getting information from them. So please pause the video right now, take a look at this graph, and determine the following information about the graph. We want to know the velocity at t equals 18, the slope at t equals 35, the area under the graph between t equals 0 and t equals 21, maximum velocity, and the spots where the slope is 0. So go ahead, give this a shot, and then we'll come back in a minute. Okay, first question, what is the velocity at t equals 18? Well, here is t equals 18. At that spot, my velocity is this value for velocity. I would call that, I don't know, maybe about 30 meters per second. It's an estimate. As long as you know you can read the graph like this, that's fine. You effectively got this question correct. I'm estimating it's about 30. It might be a little higher or lower than that. Okay, what is the slope of the graph at t equals 35? So at t equals 35, that is this point here. So notice we got a straight line here. How do we find the slope of a line between 2 points? Well, we do this with rise over run. Slope equals change in y over change in x. These deltas mean change. And we can get this by saying that our slope is equal to, that's not what I wanted. Our slope is equal to y of 1 point minus y of the second point over x of 1 point minus x of the second point. So let's take the slope between these 2 points, and it will tell us the slope of the entire line. So the y of this point down here is 0. The y of my point up here at the top, I'm going to call it like 120 maybe. I'm estimating, I'm saying that this is about 120. Again, you might think differently, that's okay. Down here, my x is going to be 37. And over here, my x is that's 37. And then over here, it's like 30. So we get negative 120 over 37 minus 30, negative 7, which will come out to about, let's use the calculator for that. 120 divided by 7. It's going to be a little over 20, or a little under 20, I mean. Yeah, 17.1. 17.1. All right, so there's our slope. Excellent. All right, now, next part. What is the area under the graph between t equals 0 and t equals 21? Okay, so t equals 0 is over here. This line's supposed to go down here. T equals 0 is over here. T equals 21 is right here. So I want to know what the area under the graph is for this. In calculus terms, this is called taking an integral. This is very, very useful in physics. It's more useful in calc-based physics, but it's still quite useful in algebra-based physics too. In calculus, you're going to use integrals, calculus function for this. But we actually can just use algebra to find the area under this graph by approximating these as geometric shapes. Notice, what does this look like to you? You could call this a trapezoid, or you could also call that a triangle and this a square. We know what the area of a triangle and a square are. A triangle has an area of 1/2 base times height, right? A square has an area, or a rectangle, sorry, I call it a square, it's very clearly a rectangle, my bad, has an area of length times width. Okay, so we can use these to determine how much area is under the graph for these parts. So, okay, between t equals 1 and t equals 7, so this length of this triangle here is 7, that's our base. Our height here, I'm going to call like, I said 30 earlier. So 1/2, 7 times 30 will give me the area underneath this curve, which comes out to 7 times 15, which is what? It's like 105, I think. Let's go. It's 105. So this area here is 105. And then this rectangle here is between 7 and 21, so it's got a length of 14, and it's between 0 and 30, so it's got a size of 30, or a height of 30, excuse me. So then 30 times 14 is 420. I did not do that on purpose. So then 420 plus 105 will give us the total area under this section of the curve, which is 525. Boop. Okay. Next question is easy. What is the maximum velocity of the object? The maximum velocity, where the velocity is highest, is going to be right here. Right? Our velocity is this value, so our top point here is the maximum velocity. So it's going to be velocity equals 120 thereabouts. I estimated it earlier as being about 120. And then the last question, please label where the slope of this graph is 0. Slope of a line is 0 when it's flat. So here, the slope is 0, right at this spot, over top of our rectangle that we drew. I want to do that in a different color so it's easier to see. Green. M equals 0 in the green spot. Okay, so now we've analyzed this graph. That'll be very useful for us later. Thank you guys so much for watching my videos. I hope that you learned something. Have a great time. I'll see you next time.